Hi, welcome to Mimi Math. Today we're going to look at side proofs. Well, first of all, you need to know what triangles look like when you're trying to use the side postulate. So let's look at a few examples first. Okay, here's this first one. We have side AB, and it is marked congruent to side DE. So we can list DE is congruent to AB. Okay, so there is one side that's congruent to each other. Then we've got these sides that are marked from A to C has 2 marks on it, and from D to F has 2 marks on it. So I'm going to list that as AC is congruent to DF. And then the third side, BC, has 3 marks on it, so BC has to be congruent to EF. So once you get 3 congruent sides in a triangle, you know that the triangle has to be congruent. So that's when you use side. It's actually one of the easiest postulates to see. So let's look at this next one. Okay, we have one large triangle, but then when we draw this altitude in to this base, you can see that it creates 2 smaller ones. So you can see that NY and PY are congruent to each other. Those segments, this altitude bisects it into 2 congruent parts. And then you can see that QP and QN are also marked congruent. Okay, so if you're looking at these 2 small triangles, you can see that we have 2 pairs that are congruent. So let's write that. NY is congruent to PY, and then QP is congruent to QN. Okay, now the third side, let's see, we've got this third side here, QY. QY is in both triangles. It's in the top triangle and it's in the bottom triangle. So QY is congruent to itself. So there's a third part. So you can see we have all 3 sides that are congruent. So this one would be a side. Now let's look at this last one. Okay, this last one, you can see we actually 1, 2, 3, 4, 5 triangles. Okay, we have the 3 small ones, but then we have 2 larger ones. So what we're going to be looking at is actually the 2 larger ones. Let's see what information we're given. We're given that AC, this whole side, is congruent to BC, this whole side. And we have, and then AD, this short side is congruent to BC, this short side. So sometimes these overlapping triangles are kind of hard to see. So I'm actually going to draw them separate. Okay, I'm going to draw ADC, and then over here, and mine's not to scale, but you can see that I'm going to draw BCD. And I'm going to mark these parts congruent. Okay, AC, that's this one, is congruent to BD, that's this one. And then AD is congruent to BC. Okay, so we're trying to get these 2 sides congruent. Well, what do you notice about these 2 sides? This one is DC, this one is also DC. So DC has to be congruent to itself. So DC is congruent to DC. They overlap and share this common side down here. So you can say by side, the 2 triangles are congruent. So there are some examples of when you see the side postulate used in proofs.